Okay, so I'm presenting this as a participant in the IBTA Management Working Group, and this presentation covers the work done in the group over the past year in efforts to standardize virtualization in InfiniBand. I'll cover, sorry? Can you hear? Okay. I'll cover most of the aspects of the annex. We're progressing pretty nicely. Almost everything is hardened out, few remaining issues, and the drafts are evolving nicely. So, a little bit about the goals that we set to achieve. So, first of all, we wanted to have scalability. Both be able to support a lot of virtual endpoints that are represented behind nodes in the fabric, and support those in an efficient manner in the fabric. We wanted virtualization to be explicit, namely that the explicit nature of InfiniBand management that knows about the endpoints would also know about virtual endpoints. We want it to be simple, both in terms of management and implementation. And finally, we want it to be backward compatible, both in terms of interoperability with other nodes in the system that are not virtualization aware, but also with fabrics that are managed by SMs that don't know anything about virtualization. And in that case, we want to cleanly fall back to at least one transport entity in a node that can just work like bare metal HCA. One thing I want to, regarding being explicit is, for one good example for that is partitioning. So as you can see on the right-hand side, I still want to be able to restrict virtual entities to specific partitions in the fabric. So the main concept is virtual HCAs and virtual ports. Virtual HCAs are basically independent consumer interfaces. They have their own resources. They have their own namespaces, so QPs, Shreks, CQs, etc. And these virtual HCAs are connected to the fabric by lightweight transport endpoints called virtual ports. And these have all what is needed in a port in terms of transport, but all of them share the attributes of the physical link. Let's have a short look at what a virtual port looks like. So you would recognize the standard attributes that exists in physical ports. They have GID tables, PKey tables. They have a port state, logical, right? They don't have any physical link, but they do have a port state. They have their own capabilities. They have canners that monitor their violations to PKeys or QKeys. And in addition to those attributes, we have added several new concepts. The first is to be able to add a lid per VPort, which basically makes endpoints multi-lid. We also added a field called profile, which adds a type to a port. So essentially, you would like to configure these virtual endpoints in the fabric instead of a list of GUIDs, like in the subnet management, but rather by a type. So for example, tenant A gets these PKeys and this quality of service. And the moment some node joins the fabric with some profile A, then management knows what to do. It doesn't need to have a priori a list of the identities of the nodes that would be joining that that type. Another new notion is the SL mask, the ability to restrict virtual ports to specific SLs. As we know, in InfiniBand, DSLs are both means for relaying packet in a complex topology, but they also serve as a sense of quality of service. And we might not want to have all these virtual entities sending packets on all SLs. Like if we have a high priority SL, maybe want to prevent some entities from being able to do that. So subnet management can restrict the SLs, and the HCA hardware enforces that restriction on the virtual endpoint. And of course, the management has to be aware of these restricted SLs, so when other nodes issue path queries, only valid paths with the proper SLs could be returned. And all these virtual ports, they share the physical ports. So here I just put a few of the standard fields on the physical port level that are not per VPort. We've defined two VPort types. VPort 0 is the privileged backward compatible one, and the rest. And the differences are summarized in the table here below. So let's first look at GID peaky table capabilities. VPort 0 just mirrors those of the physical ports, and that's what makes it backward compatible. If virtualization is not enabled, any virtual HCA that is associated with VPort 0 just works with whatever the same program the physical port. In terms of privilege, only VPort 0 can access the subnet management, and also the raw ether type and raw IPv6 interfaces. All the VPorts can open the QPs, but their packets are not going to go anywhere. And this is because, first of all, because we still have a single SMA in a physical port. We're not changing here the model. It's completely backward compatible. And also, we don't want virtual machines having direct access to fabric management. In terms of the GSI, there is no difference. Both kind of ports can use the GSI. So let's look at the overall picture. Consider a dual port HCA, which has 3 dual port virtual HCAs. Now the decision of how many ports virtual HCAs have and how to associate them to virtual ports, or even association between a virtual HCA's port to a proper or matching physical port, is completely an implementation decision. You can do whatever you want. This is just an example. So following up with the previous slide, here we see that only the VHCA marked by GUID 0 is mapped to the VPort 0s on the physical port. Hence, it's the only one that has access to the SMA. But all other virtual HCAs, they have these interfaces, so there's no effect to the verbs. It's just a matter of permission. Let's talk a little bit about packet relay, because there's no switch here, but we do have switching concepts. We're relaying packets between virtual ports. So the relay is a combination of steering an incoming packet from the wire and loopback. I'll start with the case where we don't have any additional lids which are optional. So we have a bunch of virtual ports sharing the physical port lid. And when we look at unicast packets, any packet, basically we're steering packets according to destination GID. And all the default, anything that doesn't fall under this criteria, is steered to VPort 0. So this could be either packets whose destination GID doesn't match any GID table. And in InfiniBand, that's a perfectly well case. I mean, for example, UD doesn't care about the GIDs. It's a transport check. And also packets without any GRH. And this basically is important because it's what makes it backward compatible. So VPort 0 can just get packets without a GRH if there are nodes that cannot generate those. In terms of multicast, it's basically implied by attaching QPs. Doesn't matter from which virtual port. If you pass the PKey checks, then you're going to get that any traffic that either comes from the port or is generated by one of the vPorts in this HCA. In terms of loopback, we loop back within a vPort, and that's denoted by the blue arrow if both the dgid and the dlid match, or you set the loopback indicator either in the QP or in the address handle. And the physical port loopback is backward compatible. That's what is done today, loopback according to the lid. Now, if you want to extend this when you add lids to vPorts, basically there are vPorts with lids, and then you associate vPorts without a lid to those that have one. So essentially you're creating groups of vPorts that share a lid. Then the extension is straightforward. So basically, if you're not loopback by the GID, then you're loopback by the lid. And if this endpoint doesn't have the lid that you're looking for, you're going to go out to the wire. So that's pretty simple. Okay, let's talk about verbs. So first of all, OpenHCA returns a handle to the virtual HCA. And this is regardless of whether virtualization was enabled. We'll see in a moment that the SM needs to explicitly enable virtualization. And why that? Because we don't want to have traffic by nodes in the fabric that the SM is not aware about. I mean, specifically, it won't even know how to return path queries for them. So, but this doesn't mean that the virtual HCAs don't exist. They always exist. They exist by the implementation. And that's why OpenHCA works always, even if you're disconnected, of course. Query HCA is what you would expect. Of course, all the port attributes that are per vPort, they are returned corresponding to that vPort. But there is a new thing called GRH required, and that is because these virtual HCAs need to access the SA. And again, we're backward compatible. The information to access the SA is only the SA lid and SASL. So these virtual HCAs have to know that they need the GRH in order to get to the SA. So that's this indicator. And basically, it's only consumed by the SA module in the kernel. Usually, applications don't need to know about it, unless they're management. Modify HCA, there's nothing special. Other than that, maybe we're just restricting the SM to port 0 because it's the only one that's privileged to access the SMI. Regarding asynchronous events, if it's affiliated, it's straightforward. If it's not affiliated, of course, all the port events correspond to the virtual ports, and maybe the only thing to point out is that you get these events when either virtual port attributes change or the physical port. For example, the master SM lid, stuff like that, or something are fields that come from the physical port, and you would get the proper asynchronous event on the virtual port. Finally, client re-registrations can be triggered either on a vPort basis or globally. Okay, let's have a brief walk on changes to subnet management. So first of all, an indication of virtualization support. This is just a new capability mask. This is how the SM finds out about nodes that support virtualization, which indicates that they comply to this annex. And once they do, we have the following mandatory attributes. The first is the virtualization info, which is a summary. It's a high-level capability of the ports. So we have the maximum number of vPorts, how many are enabled at this time. The virtualization enable is that bit that basically enables VPorts to go into the active state. The SM controls when they do that, but without this bit being enabled, there's no traffic between virtual ports. We have this client register bit here at this top level to cause this re-registration to all ports. And one interesting thing to state is this VPort state change, which, if people remember, the switches have those. So whenever one port changes on the switch, they set this bit and raise a single trap, and then the SM needs to probe which ports have changed and then reset that bit. Same concept here. We don't want to flood the SM with traps and get into race conditions when we have a bunch of VMs coming up and down. So again, a single event gets raised, and then a single trap, and then the SM scans which VPorts have changed and resets this bit. VPort Info is the equivalent of the standard port info. I think what's interesting to say here is actually the attributes that don't exist here. Okay, so all the physical attributes of SL2VL and all these stuff, they have no meaning for virtual ports. The rest are the ones that you know about from the physical ports, and we have the new stuff like the profile, 2 fields for managing lid assigned VPorts, and the SL mask. These are the new things, but the rest are standard stuff. The node info is the same as for physical ports, nothing new here. And the same goes for node description, GUID info, partition table. The only difference of these attributes, I mean, they have the same format as the physical port. The only difference is that they have a VPort index indicator, so management can program these on a VPort basis. The last attribute, which is interesting, is the VPort state, and this is new. This is an aggregate. Basically, we compress together 128 VPort state elements of the VPorts, and each one is 4-bit wide, which encodes the standard port state attribute of the physical port. So once the trap is raised, the SM can efficiently scan the port state of a bunch of virtual ports, specifying a block number in a similar manner to other attributes. Regarding traps, they are basically, again, equivalent to the physical port ones. We have the first two are aggregates, meaning that a single trap is being raised or generated for the whole physical port. Could be either port state change, as we've seen before, or any kind of local change, like no description, for example. So we're raising it once, and then the SM finds out who changed. The last two are VPort specific, because we want to track which specific VPort had a violation in the partition key, in accessing the P keys or Q keys. Regarding subnet administration, VPorts other than VPort 0 or without a lid need to access the SA with a GRH, and they have to use the well-known SA GID, which will be specified in the annex. Partition checks in the SA query subsystem take into account the VPort PKey tables. And in all these SA attributes, inform info, service record, path records, providing GIDs of virtual ports is now going to be allowed. So you can query the SA and get paths to VPorts, and you can get learn about them, and VPorts can register multicast memberships just as you would have expected. In terms of performance management, we've added a per VPort statistics. They match the extended counters, which are already defined. with the addition of with one counter that's called the relay error, and this one accounts for violations to the SL mask or sending packets, attempting to sending packets without a GRH. So these are dropped by the HCA and are counted for in this counter. I'll summarize with the implications to software of for supporting the virtualization annex. So first of all, for applications, this is like trivial. They need to be able to support GRH. This is not any different than supporting routers. In terms of the host stack, we need to extend the port structure, at least in the kernel, to add this GRH required bit. And again, this is its main role is to signal the SA code to generate SA queries with a GRH. Of course, the annex doesn't touch on how you use virtual ports. This is completely an implementation decision. One common implementation is to use virtual ports for SRIOV. So if you're doing that, then you need to probably manage your VFs. So you can control their identity, their port state, and other attributes. This is out of the scope of the IBTA. Basically, all these attributes show up as read-only to the SM. How they got there doesn't interest the SM. But you do need APIs, and I think in recent days we've had an upstreaming of IP over IB NDO operations that control SRIOV for InfiniBand in a similar manner to how Ethernet SRIOV is controlled. Regarding the SM, after you initialize the physical ports, you need to discover and initialize the virtual ports, and then you need to react to VPort state change according to the various traps, and then react appropriately. The SA needs to honor or process GIDs of VPorts. And finally, management tools. You would like to see, when you look at the topology file, you might want to see the virtual ports that are behind physical nodes. So since everything is now explicit, then the tools should be able to drill down one level down and show you the virtual HCAs. I think, yeah, that's about it.
Test. Can you compare and contrast a little compared to like the virtualized HCA that we were seeing yesterday? I think it was Oracle's presentation. Why the frame relay would be picked over something like a virtual switch?
Mm-hmm. The virtual switch that we've seen is basically it's standard InfiniBand. If I understood what they're doing correctly, they're not introducing a new element. They have you're emulating a switch or implementing a full-blown InfiniBand switch backed by regular HCAs. But then you are you're mandating that each of the VFs use lids. You're assigning a lid to the virtual switch. Subnet management now has an order of magnitude more management to do because you need to configure and raise each of the links between the virtual switch and each of those HCAs. I mean, it's good in the respect that it's a standard HCA and a standard switch, but it increases a lot the management. So maybe for smaller systems, it could be more backward compatible and transparent. But for large systems, it's going to restrict the number of lids you have and add more burden on the management. I think those are more or less the trade-offs. So actually, when we thought of what features we're adding to the virtual ports, we could have kept on adding features, and essentially we would have ended up with a switch and said, hey, what are we doing? So we tried to strike a balance between the complexity and the ability to add these lightweight virtual ports, and we stopped short of duplicating the SMI and direct hops and stuff like that. So we wouldn't be emulating just a switch. So I hope we found the right balance. And implementers have a choice.
Thank you.
Okay, thank you.